So today I'm going to share with you the peer-to-peer electricity trading. So my presentation basically is just give you an overview and how it works, but not too technical. So first of all, let us zoom in the conventional structure of the distributed RE. So like the diagram shown here, we have the resident with the solar and also resident that without solar. Then of course, those that without solar, so we will need to buy the electricity from the utility at the domestic tariff. And those that with the solar, if it is not sufficient, then still will buy from the utility. And if there is a excess of from the solar, then can sell to the utility either at the feed-in tariff rate or the power purchase agreement, like for example, under the net metering program. So next is a little bit about the motivation and driver. So even though we have the current structure of the distributed system, but still getting more people that they are looking for flexibility in controlling and managing, the resources that they generated. So for example, they were curious on whether they can sell the excess electricity directly to the neighbors, or even like, selling on at a desired price, that not fixed price like the feed-in tariff or the PPA. And besides that, we also know that, currently there are advanced technology that already developed. For example, the smart meters that have been mentioned a lot from the two speakers. And then we also have the current technology on this distributed ledger technology like the blockchain. And besides that, also have the P2P services like we all know, like commonly known that we know the Airbnb and also the Uber. And besides that, we also have the AI technology that already at the advanced stage. So combining all of this, it leads to a disruptive innovation, which is the P2P electricity trading. So what is that about? It's in fact a virtual marketplace that allowed the participant to buy and or to sell the electricity directly from each other. So commonly it will incorporate with the blockchain technology, which the blockchain is basically a database technology that processes and store information, including like all the transaction of the amount of the unit and also the sell and purchase orders. And for the participant, there are two groups of the participants under this P2P electricity trading. So one group is called prosumer. Prosumer are who both can sell and also consume the electricity from the distributed solar. And for the consumer, those that they do not have the solar by themselves, but they purchase the electricity from the distributed solar. And the beautiful part of the P2P trading is that the prosumer can sell the electricity at their desired price to the consumer that are willing to pay for that price. So for the network-wise, basically, we can see here there are two main layers. One is the virtual and the other one is the physical. So for the virtual here, which is including the blockchain technology here. So it will record all the information flow here, and we can see it later on. And then I will explain it on, but then I just to show you there are two layers. And the other one is the physical layer, basically is to transfer how to deliver the electricity from houses to houses. So meaning it's from prosumer to the consumer. So here is the concept. So we have the virtual layer here. So the virtual layer here for the houses, they will need to install the device, such as the smart meters that connected to the blockchain platform. And for the prosumer, they can set the selling price. For example, here is the X per kilowatt hour. And so as the consumer, they can set the price that they're willing to buy for it. And the blockchain, they will find whether there is a matching sell and purchase orders. When they found one, so automatically they will have the financial transaction. So for the consumer, they will need to pay for whatever price that they have agreed on. And for the prosumer, they will move on to the physical layer, which is to transfer the electricity from the prosumer to the consumer. So next, when we talk about trading, one important point, of course, is the business models. So there are a lot of different business models around the world. So I've just chosen a few of them that to share with you, and so that you will have an idea how it works. So the first example is the Malaysia pilot run. So this is an initiative that initiated by the Sustainable Energy Development Authority, or SEDA, and partner with the Power Ledger. Is an Australian technology company that provide the blockchain services. So, and this pilot run is implemented under a regulatory sandbox framework, which means that it allowed the testing of financial technology because it involved trading, and then in a live environment, but it's still not like fully freedom to do everything that you could, but you have to fulfill a certain regulatory requirement. So for this case, the government is still monitoring for the whole system. So the pilot run lasts for 8 months between 2019 and 2020, and is offered to the prosumer and consumer who is under the net energy metering program. So here is the concept. I'm not going to explain the virtual and physical since I already explained, but straight away I will share with you how the business part, how the trading goes. And just like to mention that for this pilot run, the trading is actually through the national grid. The TNB is our utility, national utility. So it's through the national grid. So for example, here, the prosumer, they can sell the price at the industry tariff, which is 10% more than the typical industry tariff. So it will be around 40 cent ringgit Malaysia per kilowatt hour. And for the consumer, if they would like to buy the electricity from this P2P program, so they will need to pay the price that the prosumer sell, which is the 40 cent, about the 40 cent, plus a little charge on the network charges, which is at the total, they will need to pay around 45 cents per kilowatt hour. And this price is still cheaper than the typical commercial tariff, which is about 51 cents per kilowatt hour. And the consumer in this sense will save about 11% of the tariff. And you can see here, there's no retailer fees. So, and also from here, probably you already have an idea. So for this pilot run, obviously the target consumer is those that under the commercial tariff, because otherwise we cannot see the incentive, because you can see here, the typical commercial tariff is actually higher than the industry tariff. So this is how it works. And what are those lessons learned from the pilot run? The stakeholder, including the government, they actually have a better understanding on the concept and also the potential benefit of the P2P. And also it's easier for the government or even the stakeholder to identify the technical requirement for the real implementation. And one important point that the government learned is that in order to encourage the participant, the economic return is a key. And the other point that have to pay more attention is because for this pilot run system, if there is any untraded energy, it will be it will be fit into the grid at zero cost. So in this case, the prosumer is actually experienced financial loss. So, and because there were a few months that the supplies is even more than the demand, because the size of the consumer is too small. So the demand is actually lower than the supply. So what we have learned here is also the size of the consumer is also a key point there to make it a success. And the next example that we'd like to share is Your Neighborhood Solar at Victoria, Australia. This is a program that launched by the Power Shop, an online electricity retailer. So the idea is to take the excess solar from the customers and put it back into their local energy distribution area. And for the participant who would like to participate in this program, the customer of the Power Shop will have to buy the power pack. That's the name is Your Neighborhood Solar Power Pack. And for the prosumer, they sell the electricity to Power Shop at the feed-in tariff price at around 7 cents per kilowatt hour. And for all the customers who purchase this power pack, in fact, they will need to pay a premium of 4 cents per kilowatt hour. And when Power Shop will collect all this premium and become like pooled together. And when they have the total fund of this pool, at the end, they will distribute it back to the prosumer according to the capacity that they sell to the Power Shop or to the grid. So during the trial period, the prosumer found that they actually earn 48% higher than the Power Shop regular feed-in tariff, because without this P2P, they only earn this 7 cents. But with the P2P, they earn the extra profit that is from the premium pool. So for the consumer, anyway, they will have to spend an extra $9.40 on their bill over the month. But then it's still cheaper if compared to the Green Power Pack. Green Power Pack is the government scheme that encourage, give opportunity for the people to purchase renewable energy electricity. So if you comparing with this Green Power Pack, the P2P is still cheaper, even though have to pay extra $9.40. So this is P2P will be more attractive to customers who support renewable energy. And from a survey, 89% of the customer with this power pack, they thought that they want to support this is because of they support solar. And 71% of them says that they will actually continue to buy this product. So the next one is the Brooklyn microgrid at the New York City, US. So this is a community-driven initiative since 2016. And what's the difference between this one and the previous two examples is that this is a completely microgrid. That is the grid is like the community grid that because of this microgrid, so the prosumer and the consumer, the transaction directly between them. So they can sell the price through the auction. So the transaction, the trading is very direct. And the main purpose of this project is to demonstrate to the regulator that the people is actually care about the energy future and they're willing to pay for renewable energy. And also they found that the P2P trading is actually can incentivize the local homeowner to install rooftop solar, and so that, and also to reduce the GHG emission. And because of the New York City, before that they experienced the Hurricane Sandy, so they know that a resilient grid is very important. So for this particular this microgrid, the physical layer, they are still connected to the main grid, but however the trading among themselves are the community grid. So they are actually independent. And for example, there's an emergency event, for example, the weather event. So this community grid can completely shift to island mode, which is completely independent from the main grid. So they can run like on the self-sustained electricity supply. And one of the things that the people also learn here is through this microgrid P2P, they are more clear on the energy that they are using are actually from renewable energy, because you know exactly who sell to you and from where. And compared to electricity that getting from the grid that we actually pay for renewable energy electricity. But when we are using it, we not that certain whether are we using the renewable energy electricity. So the last one is a community project, which is the community first village in Austin. So this is not exactly the trading, but I thought I would like to share because it is more to another benefit besides, you know, all the profit related. This is more to humanity. So this is developed by a community organization that you know, they gather all the homeless people and form a community that offer them affordable houses. And the organization collaborate with the GridMates, which is a company that provide technology platform for energy community engagement. So they have like an app that offer for the donor. So the donor, if you would like to help this community, there are two ways to contribute. One is you can contribute in terms of dollars to help the community pay for the energy expenditures. The other way is in case you are the prosumer, so you can donate the excess solar to this community. So in fact, this is a way that to address the energy poverty as well. So this is how the P2P the blockchain technology can advance until, you know, helping the poor. So the next one is actually to summary like the benefit and contribution that I have shared with you through the example. So I'm not going to go through one by one, but I will just quickly go through it. So we know that from the example, it is a very good strategy to boost the renewable energy because the prosumer see is profitable, and for the consumer, they can save on the electricity bill. And the second one is the reliance and reliable power system, which has been mentioned through the example and also been mentioned through the earlier speakers. The next one is this P2P electricity trading also can avoid, you know, a certain monopoly power in the wholesale market, and in fact it creates like new business model because this P2P trading basically do not go through the electricity retailer. And learning from the Brooklyn microgrid, we know that if we apply the same concept to the remote area, in fact it will also improve the energy access. So the next one I just would like to share with like 3 key main points that in order for the deployment to enable the P2P electricity trading. Of course, one is the network digitalization, which is we learned that, you know, the virtual layer is in fact the fundamental of the business model of the P2P. So this is like the basic in terms of the P2P electricity trading. And the next one is very important, is also the regulatory framework. Because currently this P2P trading is still very new and there's no concrete law or regulation to protect the consumer. So everyone can just, you know, trade on a very flexible way. And so one of the possible way to do it is like the Malaysia example, implement through the regulatory framework, so that it is not like full freedom, but still you have the minimum control that have to fulfill. And the other one is I thought that for the countries that with highly subsidized tariff, maybe it's good to review the fossil fuel subsidy, so that, you know, you will have it will be able to create more attractive market that more competitive selling price, and so to incentivize the prosumer, and, you know, because of that, then we will have more solar rooftop and to address the climate change impact. And I also include a list of the references and further reading, because I already simplify a lot. So if in case you are interested to learn more, so here are some of the references that you can refer to. And so with that, I end my presentation. Thank you.